right, so we're going to graph the tangent and the cotangent. So I would suggest that you print this page out from the website so that you can actually graph these along with me. So the first one here, we're going to graph -3 tangent 2x. So the first thing I would do would come up with the pieces for this. Remember, amplitude is undefined for everything except for sine and cosine. Your tangent graph, since it's a -3 out in front, it's going to decrease from left to right. You don't have to write that, but that might be helpful for you to remember to do that. The period would be pi divided by b, which is going to be pi divided by 2. So the period is pi over 2. There's no vertical shift for this one because there's no number added or subtracted at the end. There's no phase shift for this one because there's nothing added or subtracted inside the parentheses there. So if we go through and we start to set up your graph, move that arrow out of the way. So if I go through and start to set up the graph there, 2 periods, wherever you want to put these 2 periods, I'm going to set this up, let's see, 0 to pi over 2, and then I'll put a second period on here of pi and chop that up into equal parts there. The y-axis, we should stick some numbers on there, even though they really don't mean a whole lot since we're making these x increments kind of whatever we want here. Let's stick a couple of units on this negative end as well. All right, now I need to come up with where the zeros are. So remember, the zeros for your graph will occur when this fraction equals 0. So -3 tangent of 2x has to equal 0. Well, tangent is the sine divided by the cosine. And if you set that fraction equal to 0, the part of the fraction that equals 0 is going to be this numerator. So -3 sine 2x would equal 0. If you divide both sides by -3, then you end up with just sine 2x equals 0. And then using your unit circle there, we're looking to see where is the sine equal to 0. Your unit circle, the coordinates of those points, 1, 0, 0, 1, -1, 0, 0, -1. The sine, remember, is the y coordinate. So this happens when your angle is at 0, right here, all the way around at pi, the y coordinate is 0, to pi, and so on. And it would be plus and minus as well. And that equals our angle, which is 2x. So to solve for x, I would have to divide everything by 2. So all the multiples of pi over 2 is where these zeros are going to occur. So on our graph then, we'll go up there and we'll plot those zeros. So when x is 0, your angle would have a height of 0. At pi over 2, we're going to have a 0. At pi, we'll have a 0. And the same thing in the negative direction here. It doesn't look like I went out far enough there to have a 0 in that negative direction. And then remember, halfway between your zeros are going to be your asymptotes. So at -pi over 4, I'm going to have a 0. Got a little thicker there so we can see it. Halfway between 0 and pi over 2, so at pi over 4, we would have a 0. And 3 pi over 4. And then we can connect this with a nice smooth curve. Remember, we said it was going to decrease from left to right since it's negative tangent, get close to the asymptotes without actually crossing. And that's 2 periods right there that you graph. If you want to put, these additional pieces on here, you can, but you don't necessarily need those half a period and half a period there. So that's the first one, and that one wasn't too bad. There was no shifts going on with that one there. So if you're not finished copying this down, you can pause. I'm going to clear the ink and move on to the next problem. So for this one, we have cotangent. So cotangent, same idea. We'll find the zeros and stuff for that. Remember, the cotangent decreases left to right. Since it's positive cotangent, it will stay the same, decreases left to right. The period is going to be pi divided by b, which is pi over 3. So if you simplify that, you'll get just 3 for the period. There's no vertical shift, no phase shift for this. phase shift, vertical shift equals 0. I don't know why I wrote it like that. And then your amplitude, again, is still undefined. So we'll set up one period then. Actually, a couple periods of this. So if I go 0 to 3, that should be one period. And then we'll stick one on the other side here. All right, and then again, we need to come up with the zeros for the function. So I'm going to ignore this problem here for a minute. So the zeros would be where cotangent equals 0. Cotangent is cosine over sine. And if that fraction equals 0, it would be the numerator that equals 0. So where cosine pi over 3x equals 0. Again, if you think back to that unit circle that we just looked at, the cosine is the x-coordinate. The x-coordinate is equal to 0 up top there, which is pi over 2. And the bottom here at 3 pi over 2. And if I continued on, it would be 5 pi over 2 as well. And also in the negative direction, same values, negative pi over 2 and so on. And then this equals my angle, which is pi over 3x. Well, I don't want pi over 3x, I want just x. So if I multiply both sides by 3 over pi, on the left-hand side there I'll get x. On the right-hand side the pi's would cancel, so I would have 3 over 2. 3 times 3 would give me 9 over 2. 15 over 2, and so on. And then I can plot those points on there. Remember, let's see here. So 3 over 2, that's 1.5, so that's going to be a 0. 9 halves, that's 4.5, that's going to be a 0. I don't have 15 pi over 2, or 15 over 2 on here, but I do have negative 3 over 2, which is negative 1.5. And then we talked about halfway between these zeros are going to be asymptotes. So halfway between negative 1.5 and 0.5 is going to be, 0 would be an asymptote. Halfway between would be at 3, I would have an asymptote. And then following that same pattern, 6 would also have an asymptote. Negative 3 would also have an asymptote if you keep following that same pattern. And then my cotangent graph here, we said decreases from left to right. So my graph is looking like that. All right, so we graphed 3 periods for that one. Okay, if you're not finished copying that ink down, pause the video and you can finish copying that. All right, we're moving on to number 3 then. So this one's a little more complicated because we do have a shift for this one. We'll go through and solve and get it all set here. So again, amplitude's undefined. Period would be pi divided by 1/2, which would be 2 pi. There's no vertical shift because there's nothing added or subtracted outside of those parentheses. Inside the parentheses, I have a phase shift, which would be c divided by b, and c is negative pi divided by 2. So remember, it's the opposite of the number you see inside there, divided by 1/2. And if you simplify that complex fraction, we get negative pi. So my graph is going to be shifted to the left pi units. So we'll go through and set up a period. So a period is 2 pi, so we'll actually graph more than that so we can shift this thing. Set up a second period over here. And then we'll also do a period on the negative side so I have somewhere to shift this thing left to. It's kind of squeezed in there, but that's the idea. All right, and then we need to find the zeros for this. So let's go through and set this. I'm just going to ignore this problem here for a minute. So the zeros then, so I would do this since I have left-right shift. I would set this graph up without the shift. And this is the one way I showed you in class. So my equation is tangent of x over 2 plus pi over 2. The plus pi over 2 part is what's causing the shift. So if I eliminate that pi over 2, my graph is unshifted. So we're going to come up with the zeros that are unshifted, and then we'll shift all of them. So if I ignore the pi over 2 in this equation here inside for the angle, I'll have zeros that haven't been shifted. And then tangent is sine divided by cosine. And again, if the fraction equals 0, it's the numerator that equals 0. And using that unit circle, where's the sine equal to 0? It's 0 and pi and 2 pi, and in the negative direction as well. And that equals my angle, which is x over 2. If I solve for x, I'd multiply both sides by 2, and we get 0 and 2 pi and 4 pi, and so on. So those are my unshifted zeros, and that's important. So I haven't shifted these yet. So I'm going to put these on here, but I'm going to put them on there really lightly because I'm going to need to shift them to have them end up in the point that I want them to be at. So at 0, I would have a 0 for this tangent equation, the unshifted equation. At 2 pi, I would have a 0. At 4 pi, and at negative 2 pi, I would have a 0. And now I'm going to do something a little bit darker there so I can shift each of these. Each of these points then with the shift of negative pi over negative pi, so each point has to move back a unit of pi. So this sort of darker blue is the actual zeros for this graph. And then just like before, halfway between those zeros are going to be an asymptote. And on the ends there, we would also have asymptotes, even though I don't have another point on the other side. And then again, this is a tangent graph, and a tangent graph from left to right is going to increase from left to right since it's positive tangent. Okay, and again, you can pause the video if you're not finished copying that. We're going to go on to the last one. I'll erase the ink here. All right, and then finally the last one here. Now you got all kinds of things going on. We're ending with a big finale here. So for this one, again, amplitude still undefined. Period is going to be pi divided by b, which is 1, so it's just pi. This one we do have a phase shift for, so it would be c divided by b, so pi over 4 divided by 1. And then we also have a vertical shift, which is positive 1. So we're going to do everything the same. The vertical shift, we'll just shift everything up 1 to start and use that like our x-axis. All right, so we'll set up our graph, throw a few periods on here. Vertical shift of 1, so all the magic's going to happen around 1. Period is pi. So cut that up into 4 equal parts. Let's put one in the negative direction as well, about there. All right. So to start, I'm just going to shift this up 1 unit. So I use that as my x-axis instead of the actual x-axis. All right. And now we need to look at that, the graph in terms of the zeros. So my equation, if I think of it without the shifts, it would be negative 2 cotangent. The pi over 4 is causing the left-right shift. The plus 1 is causing the vertical shift. I've already taken care of the vertical shift. So I'm going to ignore that left-right shift, and then I'll just shift these zeros. Oh, unshifted. There we go. So if I set negative 2 cotangent equal to 0, well, that's cosine divided by sine. Numerator equal to 0 would be negative 2 cosine equals 0. Divide both sides by negative 2. So we have cosine is 0. So what angle measures is the cosine equal to 0? If you look at your unit circle, that's the top and bottom, pi over 2, 3 pi over 2, 5 pi over 2. That equals the angle, which is x for this one. So these, remember, are unshifted. So let's put them on here again with a light color so that we can shift all of these points then. So at pi over 2, I'm going to have an unshifted 0. Actually, no, let's put it right up here on the vertical shift line. At 3 pi over 2, it would be right on that vertical shift line. And then 5 pi over 2, I don't have that one on here. That would be over here. Negative pi over 2, and so on. Now let's take each of those points then with a darker color, and we'll shift those to make our actual zeros. So they're all being shifted to the right, pi over 4. And that's going to be one of these little increments in here. So this one's going to end up here. That one's off the grid already. All right, and then halfway between will be some asymptotes. So halfway between those zeros would be asymptotes. So they end up over here. And then my equation was negative 2 tangent. So if I have negative 2 tangent, tangent usually decreases from left to right, so a negative 2 will make this graph increase from left to right. Here we go. We did a super hard equation. No worries.